Alright, so hi everyone, and welcome to this first episode of my math tutorial videos. And I hope that you will learn something after watching this video. Alright, so to start with this lesson, I have here a figure. As you can see here, we have a triangle. And as we all know, to find the area of a triangle, it's just simply half of the product of the base and the height, or just simply 1/2 base times height. Alright, so there are actually different formulas to be used in finding the area of a triangle depending on its kind. If you are given like a scalene triangle wherein the the side measures are different, you will need to use the Heron's formula. If you're also given the equilateral triangle wherein you have the same or congruent sides, the formula to be used is the side squared square root of 3/4. And if you're also given like the combinations of sides and angles, you will need to apply some trigonometry. It's either you will use the sine law or the cosine law, and then proceed to finding the area of that triangle. Alright, so all I have mentioned, you can find the area of those triangles because they are expressed through sides and angles. And there are actually other way to name a certain triangle, and that is through vertices. Vertices or points. And as we all know, the point could be expressed in x comma y, wherein the x is from the x-axis and the y is from the y-axis, of course. The triangle that you have seen here on the screen is expressed in points. That is, you have point A, point B, and point C. And as we connect those dots, we form this triangle. So first point we have 1, 2. So 1 for x-axis, we have there, and then 2 for the y-axis, and that makes point A. The next one we have point B. Point B we have 3 for the x-axis and -1 for the y-axis, and that makes point B rather. The last one we have point C, and the point C is being expressed by 7, 6. 7 from the x-axis, as we can see here, and 6 for the y-axis. Alright, so this is how do we form a triangle using the vertices or points in your Cartesian plane. So the question here is, how do we find the area of a triangle given vertices? As we can see here, as we go back, there are no given measures of sides. We are only given those points or vertices. So how do we find the area of this kind of triangle? Alright, so please continue watching this video I'm gonna show you on how to find the area of this kind of triangle. Alright, so suppose the triangle is formed through this point. So we have point A, point B, point C. Because a triangle has 3 sides and 3 angles, so basically it will also be consisting 3 points or 3 vertices. Suppose your point A is A, B, your point C is C, D, your point B is C, D, and your point C is E, F. So For today's video, I'm gonna be teaching you the Shoeless Method, which is to be used in finding the area of a triangle given vertices. So we'll find out later on why is it called Shoeless Method by the following. Okay, here. So first step is you list those given points vertically. So we have point A, we have A and B, point B is C, comma D, point B is A, comma D, point C is E, comma F, and lastly you have to list the first point at the bottom part. Okay, here, so you have to put back again the first point A. So if you're given like points A, B, C, you will need to list down points A, B, C, A. But of course, a point could be expressed in different, it could be X, Y, and Z, it could be R, S, T, it depends. So if you are given points like point X, point Y, and point Z, so you will need to list down those points vertically forming X, Y, Z, X. Alright? So let's focus here first. So the formula for the Shoeless method in finding the area of a triangle given vertices is we have here. We have 1/2, and then we have to multiply A and D plus C times F plus E times B minus A times F plus E times D, and then lastly we have plus C times B. Alright, so I want you to focus and observe, notice these given points. So we have A times D, C times F, E times B. What we did is just, we were just multiplying them diagonally downward. Alright, so we have there downward, and we have to subtract the product of the upward. As we can see, we have A to the F, that is starting the upward part, and we have E times D and C times B. Alright, so this is the formula in finding the area of a triangle, and it is called the Shoeless method. So why is it called Shoeless method? Because in this formula, it is just like you are just tying your shoelace diagonally downward and then upward. Alright? That is the behind story of this method or formula. Alright. So let's try to go back to our previous figure, and we will try to find the area of this triangle. As we all know, the points at this triangle is consist of points, or expressed by the points A, B, and C, where A is 1, 2, B is 3, -1, and C is 7, 6. So first step is you must list down them vertically, and you have to put the first point at the last part. So we have point A, B, C, A. So formula, we have this, and following the formula, we have area is equal to, there's always 1/2. Since we are dealing with triangles, so there's always 1/2. Alright, so first step is multiplying them diagonally downward. So we have 1 times -1 plus 3 times 6 plus 7 times 2, and then subtracted by the upward products. So we have 1 times 6 plus 7 times -1, and then lastly we have 3 times 2. To simplify this equation, so we have this one. So 1 half, and then 1 times negative 1 is negative 1, and then plus 3 times 6 is 18, and then we have 7 times 2 is 14. Subtracted by 1 times 6 is 6, 7 times negative 1 is negative 7, and then 3 times 2 is 6. To evaluate further, we have negative 1 plus 18 plus 14 is 31, minus 6 minus 7 plus 6 will give you 5. And then 31 minus 5 is, that is 26. And half of 26 is 13. And you need to add square units since we are dealing with the area. So therefore the area of this figure given those or these vertices is 13 square units. So this is actually quite long if you are not familiar with the formula. But if you will just try to follow the process or the formation of the formula and just simplify everything, and that's it. All right. So this is the Shoeless method or formula in finding the area of a triangle given vertices. But if you think that this method is still quite long, don't worry, because we have also here another method which is by using the matrices. Alright, so again we have this figure, or we have this given, the same given with the points A, B, C. A is 1, 2, B is 3, negative 1, C is 7, 6. Alright, so how do we find the area of this figure using matrices? So first step is you need to choose 2 points or 2 vertices. So as we can see here, I choose points A and B, and you and you need to get the factor of those coordinates or components. So how do we get the factor of those 2 points? To get the factor of those 2 points, you will just have to subtract the components or the coordinates of the x and y. I mean, you have to subtract the components of x and y. For example, as I choose these 2 points, point A and B, the component of x for point A is 1, and minus the component of y for point A is 3. No, the component of x for point A is 1, and then the component of x to your point B is 3, and then the component of y for point A is 2, minus the component of y for point B is negative 1. To simplify this one, it will give you negative 2, 3, since 1 minus 3 is negative 2, and then 2 minus negative 1 is positive 3. So that is the factor of the points A and B. So the next one is choose the point or use the point A and C. So the same process, subtract the components of x and y of those 2 points. So the x component or the x coordinate of point A is 1, minus the x coordinate of point C is 7. And the y component of point A is 2. And the y component of point C is 6. To subtract, we have 1 minus 7 is negative 6. And then comma 2 minus 6 is negative 4. So you have negative 6 comma negative 4 as your factor of point E and C. You will only need to use or to have two factors. But how about the side BC? In this case, we have only used two sides AB and sides AC. But how about the BC? Well, if you would like to use the side BC, you can also choose point B to A and point B to C, or point C to A and then point C to point B. Just make sure that the 2 points have common vertices or have common vertex. For example, as I choose the points A and C, and then I also choose the points A and B, so it has common vertex or common point, which is the point A. So if you will choose B and A and B and C, so the common vertex is B. And if you also choose C A and C B, so the common vertex is C. So in this case, I just use the common vertex of A. So you have now these factors, and all you have to do is to simplify these factors via 2 by 2 matrix. So still that there is 1/2 since we are dealing with triangle. So how do we evaluate or simplify 2 by 2 matrix? That is by using the cross product, or just multiplying diagonally. We have 1/2 multiplying -2 and -4, and then minus -6 and 3. This is how the cross product works. So just multiplying them closely. Alright, so to simplify this one, -2 times -4 is 8, and then minus -6 times 3 is -18, and then 8 minus -18 will give you 26, and half of 26 is 13. So we got the same area, which is the 13 square units. So this is the shortest method in finding the area of a triangle given vertices by using the 2 by 2 matrices. You will just have to get the factors, or choose 2 points and get the factors, and proceed to 2 by 2 matrix and perform the cross product. Alright, so there are actually 5 methods or 5 ways to solve for the area of a triangle given vertices, but I just choose these 2 methods, which are the shortest one. Okay, so it depends on you and where do you prefer, if you will use the Shoeless method or this matrix or matrices method. Alright, so I guess, or I hope that you have learned something today for this topic, and if you do so, please try to solve these following problems given vertices, and please try to present your solution and answers in the comment sections. Alright, so that will be all. Thank you for watching, And this is John Thank you.